All right, guys, so we're looking at surface area of prisms and cylinders today. You are going to learn most of this just by hands-on activities, but before I get you going on that, we are going to look at just a few definitions, okay? So you need to understand what bases and lateral area are of prisms and cylinders. So the main thing is that, first of all, what shape do you describe a cylinder to be? What shape do you think that that looks like? A can is what I would say. Yeah, so just in general, it's a can, right? Notice that the prism looks very similar in shape to the can. It's just that rather than having circular tops and bottoms, it's got a polygon top and bottom, right? But it still has the idea where the bases, you have two congruent bases in shape that are directly opposite of each other, right? So think back to section 12.1 where we talked about these two shapes. What makes them different from a pyramid? What happens on a pyramid that doesn't happen here?
They'll meet at one point.
Right, it would meet at one point if it was a pyramid, right? Notice that these do not meet at one point. You have the same exact shape, top and bottom, right? I'm going to give you kind of one tricky instance of this as soon as you're done jotting down these notes. So go ahead and do that real quick, and then we will look at one example. Okay, guys, take a look at this example for me real quick and tell me what is wrong with what I'm about to do. Hold on. I am claiming that what I just highlighted is the base. Why is that wrong?
Because there's not two.
Because there's not two of them directly opposite of each other. Very good. So keep in mind that the base might not always be sitting on the actual bottom of the figure. I might flip or rotate it in a certain way. So if you look at this one, you'll notice that this, while it's sitting on this rectangular face, a rectangle is not the shape of the base because you do not have another red rectangle up here that you could highlight directly opposite of it, right? So what should I be highlighting for the base? The triangles, very good. So this right here highlights my two bases. You can see I've got two of them. They're congruent and they're directly opposite of each other. So it might not be on the top and the bottom of the figure. It might be on two sides. You need to look for that. Notice that no matter what prism I make, what shape will the lateral faces always be? Always. Okay? That's something to keep in mind, is that the lateral faces around the outside are always going to be rectangles. Are there any questions on these vocabulary terms and what we're looking for? Okay. What we're going to do next is look at an activity sheet. I'm going to pull it up real fast so you guys can see what you are supposed to be doing. We'll talk through it and then I'll let you loose. All right, so let's look at what you guys are doing today. The first activity that you are going to do has two problems. Your first problem, I'm going to give you one piece of construction paper, and your job is to construct a soup can out of the paper that has a radius of exactly 1.5 inches and a height of 4 inches, and you need to use the least amount of paper as possible. Okay, you will need to verify that you have used the least amount of paper as possible by giving me the total surface area of your soup can in inches, and show your work for the calculations below. Okay, my guidelines for you on this. You should not spend more than 5, 10 max, and I will probably start cutting you off at 10, constructing the can. That should not take that long, and if you are taking more than 10 minutes, I will cut you off and you will not get to finish, and you will lose points. Okay, you need to be working through that construction as quickly as possible. Do it well, but you don't need to be taking, 15 minutes just to construct this can. What I'm more interested in here are the calculations to finding the surface area. The construction is simply to help you see what shapes you're dealing with and to see, what calculations do you need to do. It's to help guide you through that. Got it? What's more important, the work or the construction?
Work.
The work. Do you still need to do the construction?
Yes.
Yes, but you need to do it quickly. Okay? Once you have checked your answer in your can with me here, you will attempt this problem without a construction. So the whole idea is here you're using a construction to guide you through the process so you can figure out what the formula is yourself. And then you will use your formula to do the work here for this particular cylinder. Okay? When you finish this and you've checked off both problems in your can with me, all right? And this whole problem needs to be done within 25 minutes, this whole page. So this whole entire worksheet you have 25 minutes on, all right? Again, 5 to 10 minutes on the construction, so that gives you 15 to 20 minutes for your work, all right? When you're done with that, you will pick up 2 sheets of paper over on the table. It will be this worksheet. Surface area of prisms, okay? You will be picking up a sheet of paper that has this shape on it. You will cut it out, fold on the dotted lines. Again, you should not be spending more than 5 minutes on this one. You don't even get 10 on this one. 5 minutes to construct this because you don't have to cut out circles and stuff. It's pretty straightforward. All right? Then you're going to work through this worksheet that's front and back. Okay? For this, 25 minutes again for this whole entire worksheet. All right? So you're going to work through this with your cutout to help you see what shapes you have. I want your answers on this in simplified square root form for the front and the back side. Okay? So on the front side, you're working through the cutout. On the back side, use what you did on the front side to help you through this prism. You should be done with both worksheets in 50 minutes because I still have a 15-minute lesson at the end to tie it all together. Okay? We all know what we're doing? Okay. Very nice. Again, let's get going. Okay guys, so just a quick reminder. You should be spending about 15 minutes on this first problem, 15 minutes from this point on. Okay, so 20 minutes total, maybe 15 to 20. And you should be using pi is equal to 3.14, and you should get the exact same number as me when I check it. Okay? All right, for problem number 2, you should be spending about 5 to 10 minutes. And again, using pi equals 3.14. Okay, to study the surface area of prisms, you need to cut out this shape. Spend about 3 to 5 minutes coloring this and cutting it. And then you will answer the following questions. Okay, once you've got your cutout, answer the following questions. You should be spending about 15 minutes going through these problems and answer everything when possible in simple square root form. Once you finish problem number 1 for the prisms, try problem number 2 without having to make a construction using the knowledge that you gained in problem number 1. Again, you should be spending about 5 to 10 minutes on this problem. And again, you should be answering in square root form. All right, guys, so from the activities that you just did, from the first activity, you should have found that the surface area of any cylinder you can find by finding the area of one circle and multiplying it by 2, right? For the top and the bottom. You should have then found that the area of the lateral stuff was just the area of a rectangle. And I'm going to make a couple extra notes about that rectangle so we all make sure we're on the same page. So for that rectangle, what did you find was the length? Not as the actual number, but like in general, what is the length of any rectangle around a cylinder? It's the circumference, which the circumference formula is 2 pi r, and then the height of that, right? So when you're finding the area of this rectangle, it's always going to be the circumference times the height, which will be 2 pi rh, right? Always. And then for the 2 circles, what's the area of one of your circles? How do you find the area of a circle? Pi r squared. Very good. So just things to keep in mind that those are the formulas you're using for the circle and for the rectangle. Are there any questions here? Okay. Now, in the formula or in the problems I gave you in the activity, you guys were trying to find the surface area if I gave you a radius and a height, or a diameter and a height, right? What's a way that I could switch this up that I've done in the past for similar types of problems? What's a different way I could ask these questions about the same formula? Okay. I gave you a radius and a height in the two problems that you worked on, right?
Yeah.
Or a diameter and a height.
Yeah.
How could I make this a little different?
You could maybe give a radius.
That's what I gave you.
The length.
You need at least two pieces of information.
You give them the length.
Length of what?
The rectangle.
The circumference? I could give you the circumference, sure, right? A little bit trickier? I'm asking what would be a little bit more trickier even than that. If I gave you the surface area and asked for either the radius or the height.
Yeah.
Okay. So let's look at a problem like that. All right, so I want you to find the height of the cylinder. Notice at this time I did not give you the height, but I did give you a surface area and also the radius. You need at least two pieces of information here. So let's try this problem real quick. So first things first, I'm going to draw a little sketch. I've got a cylinder whose radius is 5. Okay, so this distance here is 5. And whose height I don't know, so what should I put for the height? X. Okay, and I know that the surface area is going to be 220 degrees, or not degrees, I'm sorry, I don't know why I just said that, 220. So what we want to do is write a formula for the surface area and set it equal to 220. So based on the last slide, give me 1 second, Bree. Based on the last slide, what's the formula that I'm going to write? What shapes am I adding up? Let's just do it that way.
2 circles, 1 square.
2 circles. Very good. And plus 1
Rectangle.
rectangle. That's what I need to add up. That is what is going to equal 220 or 220. I don't know why I want to say degrees. Do we all see what I'm doing here? Okay. What is the area of one of the circles? How do I find that?
2 pi r?
No.
Or pi 5 squared.
Pi 5 squared. Pi r squared. Very good. Okay. How do I find the area of that rectangle? So what is the length of the rectangle? In general, what is that distance called? Circumference. How do I find the circumference of this circle? 2 times pi times 5. But I can multiply the 2 and the 5 together to get 10 pi, right? And then what's the height of the rectangle? We don't know, so we'll call it X. So what is the area of that rectangle then? What is the area of this rectangle if its height is X and its width is 10 pi?
10 pi times X.
10 pi X. Very good. That equals 220. So what I'm trying to do now is solve for X. I'm going to start simplifying this a little bit. Take a look at this first part. What is 5 squared? Times 2? With a pi tacked on still, right? I am going to go ahead and solve this in terms of pi just because, whoa, I know, 50 pi. I'm going to solve this in terms of pi because it's the more difficult way to do it, and then I'll explain what you would do with the calculator at the end. All right, what should I do next? What?
Isolate X.
Isolate X. How can I start isolating X? Okay, he said that right. He said subtract 50 pi. What do you think is a common mistake here? What, yeah, people want to add these to be 60 pi x. Why can't I add these together? One has an x, one does not. That is the most common mistake. We can't add those, so in order to isolate x, I'm going to have to move the 50 to the other side since it can't be combined. So I'm at 10 pi x equals 220 minus 50 pi. And then how do I get x by itself overall? Divide by 10 pi. Yep, if I divide by 10 pi here, everything cancels. Divide by 10 pi, divide by 10 pi. So let's see what happens on those other two pieces. 220 over 10 pi, what cancels?
10.
10, right? You've got a 0 on the end of each of these things. So this 0 can cancel with this 0. That will leave me with 22 over pi. On the rest of it, what cancels over here?
5.
The pi's and the zeros, right? So what is that left with?
5.
Minus 5. Yep. And this is my height. This is my final answer.
You can have pi in the denominator.
You can have pi in the denominator. Yep. Bree, did you still have a question?
Yeah. Will you specify when you want to use actual pi in our calculator and then leave them in order?
Yep, I will. The textbook does not, so on your homework, use the calculator button. So give an answer in terms of pi, like this, and then also punch it in on your calculator with the actual pi button and give an approximation in your book. Yep. On the test, though, I'll be very clear about what I want you to do. Okay, next example. So the next thing you did in your activities was after you looked at the surface area of a cylinder, you looked at the surface area of a prism, right? Overall, you should have found that your method for finding the surface area of any prism is to find the area of one base and multiply it by 2. Remember that it's key that you pick out correctly what is your base shape, right? That has to happen correctly. How you find that area is going to depend on the shape, whether it's a triangle, quadrilateral, pentagon, hexagon. That could all be different methods, right? That's all from the past few chapters. Plus, all of the rectangles that make up the lateral faces. Are those rectangles necessarily all going to be the same exact dimensions as each other? Not always, right? So you might have to do some work to figure out what a missing side is on one of your rectangles, right? Okay, just like the last problem, I gave you guys problems on that work or on the activity where I gave you enough information for you to find the surface area. But I could switch this around and ask you to find a missing dimension given the surface area. So let's do another one like that. All right, so here I'm giving you a prism. What is the shape of the base? Square, yep. So you can kind of see that you could count this as your square base, top and bottom, right? So when I'm writing my formula for this whole thing, I'm going to have two bases, which are going to be two squares, right? Plus my rectangles. And all of that is going to equal what? Not 60. Is that what I just heard somebody say? Surface area should equal what? Yeah, it's the only number that's up there. 80. Right? So if I take my two bases and add them together, and I add up all of the rectangles around the outside, that surface area should equal 80. So what is the area? I've got two of my bases. What is the area of one of my bases? How do I find that?
3 times x.
3 times x. Very good. Plus, and now I need the area of all of my rectangles.
3 times 7 times 4.
Okay, not quite. So he just found 3 times 7, and then he said times 4, but do we know that x is 3? Not necessarily. So I should have been careful when I said square base, right? Rectangle base would have been a better word to use. Because we don't know what x is necessarily. Could be a square, may not be. So I have 3 times 7. How many 3 times 7s do I have? Yeah, because the one opposite will be 3 times 7. So I can do 2 3 times 7s, and then what's my other 2? 7 times x for the front and the back, right? So for this back one and for the front one, all of that should still equal 80. So I get 6x plus 42 once I multiply all that out, plus 14x equals 80. 6x plus 14x is 20x. 80 minus the 42 is 38. And if you divide by 20, you will get x is 1.9. And then you have found exactly what you want to. Are there any questions on these working backwards problems when you're given the surface area and you need to work backwards to find one of the dimensions? Okay, so your homework due for Thursday is this. It is posted on Schoology. Please make sure that you put really good, strong effort into this assignment. We're just going to keep on getting a little bit more difficult from here. The pyramids are going to be more difficult to find the surface area, but it'll still be the same concepts. So make sure that you're good on these base shapes first. So when I move on, you're kind of ready to move forward with me.